Okay, everyone. Today we will start with a new unit, which is called reasoning. And the first lesson is inductive reasoning. So now we will see a pattern. So what inductive reasoning is making a statement, figuring out what is happening based on what you see and observe on the previous cases. So on the first example that we have here, we have figure 1 is a triangle, figure 2 is a triangle with another triangle inside upside down, and figure 3 is a triangle again with 3 triangles inside, and figure 4 will be something like, let me draw that, will be a triangle like this. And then inside of it, we will have like 3 triangles at the bottom, like this. 1, we'll just stop the video and then you will see at the end what it is. So I went off the recording and he recorded this figure here. So as you see here, you have 1, 2, 3, 4 triangles and 3 triangles upside down, let's say. And the figure is logical continuous of figure 1, 2, and 3. So now the statement that you can have here, or what it is that as you see on figure 1, you have 1 triangle that is pointed up. On figure 2, you have 2 triangles that are pointed up. On figure 3, you have 3 triangles at the base pointed up. And on figure 4, you have 1, 2, 3, 4 triangles at the base pointed up. So you can easily say here that the inductive reasoning that you will draw based on this configuration will be the number of figure is the same as the number of triangles at the base pointed up. So if we have now, if you have, let's say, this is telling us that if we have the 15th figure, someone is asking you to draw the 15th figure, then you will draw a triangle in which the base starts with 15 triangles pointed up, and then you continue until you fill it up everything. Okay, so let's move to the next one. As you see on figure 1, we have a trapezoid, and then at the top part of the vertices of trapezoid, we have 2 small trapezoids, and then at the figure 3, at each of them we have 2 other. So each of the points of the upper points of the trapezoid, we have 2 other trapezoid. And now I will get off the video and draw the figure 4 so you can see. Okay, so figure 4 will look something like this. First trapezoid, and then on each of them 2 trapezoid, and on each of those 2 trapezoid, and on each of those 2 trapezoid. So you can draw the conclusion here that the number of trapezoid at the top is double the number of trapezoids at the previous row. So if on the first row we had 1 trapezoid, on figure 2 we have 2, which is double 1, On the third figure, we have 1, 2, 3, 4, which is double the previous one. And on figure 4, we have 1, 2, 3, 4, 5, 6, and one more here, 7, 8, which is 4 number like the number of trapezoid in the previous one. So you can say here that the number of trapezoid in the row in the figure is double the number of trapezoid, the number of trapezoid in the previous figure. And we are talking here about the number of trapezoids on the top only, not the total number, of trapezoids. Let's see now this figure 1 or figure 3 or example 3, sorry. On figure 1 we have one circle. On figure 2 we have two circles, one at the original and then another one is added. On figure 3 we have 3 added, so 2 on each. And on figure 4, again, to save you time on my wonderful drawing, I will draw it and then you can see what it is. So figure 4 will look something like this. We have one circle at the top, and then we have 3 circles at the bottom and 2 circles at 3 circles at the top and 2 circles at the bottom. So you can draw the conclusion here that the number of circles at the bottom is 1 less than the number of figures, while the number of circles at the bottom is 1 less than the number of circles at the top. So this is the reasoning of it, or what we notice, and this is called again inductive reasoning. So you can say the number of circles at the top, number of circles at the top is 1 less than number of figure, while the number of circles at the bottom is 1 less than the top, the number of circles at the top. So now you may say that if we have, let's suppose, figure 10, then you will draw 1 circle, and then you will draw 9 circles at the top and 8 circles at the bottom. So this is pretty much what inductive reasoning is. So now let's take a look at the numbers, the number patterns. When we multiply 1 by 1, then the product is 1. When we multiply 11 by 11, then the product is 121. When we multiply 111 by 111, then the number is 12321. Then 1,000, 1,100, yeah. So 111 times 111 is this. And now we can say what is your prediction here on and we multiply 1, 1, 1, 1, 1 by itself. So I will stop for 1 second and then you can tell me what is. So if you don't even use the calculator, but you just see the pattern of the product of 11, 1 is following here, then you can say that since we have 1, 2, 3, 4, 5 digits of 1 that are multiplied between each other, then the product will be 1, 2, 3, 4, 5, and then 4, 3, 2, 1. And you can check in your calculator and see 1, 1, 1, 1, 1 times itself. And then the product will be what you see here. So now if you have, let's suppose, to multiply 1, 3, 4, 5, 6, 7, 8 times 1, 2, 3, 4, 5, 6, 7, 8. And then you can say that is 1, 2, 3, 4, 5, 6, 7, 8, 7, 6, 5, 4, 3, 2, 1. And you can check it in your calculator if this reasoning is right or not. So now on the next example, what we have is 1, 2, 3, 4, 5, 6, 6, 7, 8, 9 is multiplied by 9 and by 1. And then the result is 1, 2, 3, 4, 5, 6, 7, 8, 1s, and followed by a 0 and then a 1. And then when you multiply 1, 2, 3, 4, 5, 6, 7, 8, 9, so again, when we have 1, 2, 3, 4, 5, 6, 7, 8, 9 multiplied by 9 and 2, then the result will be 1, 2, 3, 4, 5, 6, 7, 8 digits of 2, followed by 0 and a 2. And then you multiply by 4. Now, what do you think that the result here without using the calculator will be? Hopefully you are saying that the result of, based on this pattern, will be 1, 2, 3, 4, 5, 6, 7, 8 fours, followed by 0 and a 4. So now if we have to, based on this inductive reasoning, if we have to multiply 1, 2, 3, 4, 5, 6, 7, 8, 9 times 9 times 8, then you will know that you will have 1, 2, 3, 4, 5, 6, 7, 8, and you can check it in your calculator if this reasoning is right or not. In the examples that we just finished, we made a conclusion based on the pattern of the observation that we see. So this is called inductive reasoning. So you make, based on what do you see, you make a logical conclusion of what will happen to the next or what will happen to the following. Using inductive reasoning, we can arrive at conclusion which is in general an educated guess based on the observation or based on the pattern. And those conclusions are called junctures. So you are reaching a conclusion based on the observation and on the pattern. And now we actually wrote the conclusion or the conjunction based on the observation. You can go back to the previous slides and then see the conclusion that we just wrote. Now, Jeremy investigated the following pattern. 1 plus 2 plus 3 is equal to 6. And then 5 plus 6 plus 7 is equal to 18. And then -6, -5 plus -5 plus -4 is equal to -15. And then a -12 plus -11 plus -10 is equal to -33. So what do we observe from those examples here is that numbers that you are adding are all consecutive numbers, consecutive integers, I should say. So when we have 1 and 2 and 3, those are one after the other. This is the meaning of consecutive. 5, 6, and 7, one after the other. -6, -5, -4, one after the other. So you are adding 3 consecutive integers. Now, let's take a look on the other side of the result. 1 plus 3 plus 2 plus 3 is equal to 6, which is, you can say 2 times 3 or 3 times 2. Okay. And then next one is 5 plus 6 plus 7 is equal to 18, which is definitely 3 times 6, which is the middle number here. And then we take a look at this, -6, -5, -4 is -15, which is triple of the middle number. And then the last one, -33, is triple the middle number, -11. So you can say that when you add, so this will be the conjunction, when adding 3 consecutive integers will result into triple the middle integer. This will be the conjunction here. And now if you have, so write one more number of pattern at the end of each sentence. You can write any positive or negative. So on this case, we can say that 8 plus 9 plus 10, and the prediction that we made is 27, which is 9 times 3. If you check in your calculator, you will see that 8 plus 9 plus 10 is equal to 27, which is a correct one. And now if we take a look at the negative numbers, then we can say -100 plus -99 plus -98 should be equals to -99 times 3, which is -297, because middle number is -99 times 3 is -297. And now if we try and check in your calculator, then you will have, even from your calculator, you will have the result of -297. So after you are checking and proving the reasoning that you are having, the conjunction that you are stating, then you can say that this is the right one. The assignment that you will work on is on page 12 to 14, 1, 6, 7, 8A, and 11. And this is the lesson. We will continue with lesson 2 today, because today you will see 2 lessons. As you see, they are very simple. So for reasoning, we'll combine 2 lessons together.